You ready for us to start?
Afternoon and welcome back. Hopefully you've enjoyed the day so far. If you're just joining us, my name's Bill Plourd, and we welcome you to eFAB Expo Day 2 on behalf of Southern States Machinery, Mid-Atlantic Machinery, and Northeast Machinery Sales. Thank you for joining us. We'll get right to it. We apologize for the technical difficulty. So let me introduce Dave Lodge with InspecVision. InspecVision is a parts inspection system for 2 and 3D models for your parts. I'll let Dave talk more about it. We're running a little late, so I don't want to take up a lot of time. Dave, over to you, please.
Very good. Thank you, Bill. And assisting me is John Timmerman at our office. I appreciate all the help. Yes, go ahead, John, start rolling through it. So InspecVision makes a suite of products from 2D to 2.5D to 3D. And we're going to start and roll right into it. Mute your mic, please, John. We're going to roll right into it. The idea is for an operator to place a part on the table, walk up perhaps with a traveler, scan the traveler. It will open up the file, scan the part on the table, overlay it onto the CAD model, and within seconds give you a full inspection report. Try to make it as simple as possible. That is with the pass or fail on the screen. If he sees all green, he knows the part is good. He can then print out the full report of all the features he's asked for, including any full GD&T that he may have wanted. It's very easy to get to that point of knowing what you need. You can import a file that is fully dimensioned and toleranced already. So it's easy enough for an operator to open up a file, or a programmer, if you will, to open up a file, import all the information, and quickly begin telling it to scan a part to get all the data you need. If you don't have fully dimensioned files, it's as easy as telling the system to do some auto dimensioning as well as semi-manually dimensioning every part to get all the data. Like in any system, you need to tell the system basically what you want to know. Do you want to know overall dimensions? Do you want to know diameter? Do you want to know GD&T? Do you want to know bolt hole pattern? Do you want to know, point to point? Whatever you want to know, you simply need to tell the system what you want to know one time. Save all that information, and then scan the part, and you get all that information. Okay, I'm going to let him finish the auto gen real quick, so he can quickly control the auto gen by telling it what he wants to see. Tell it where the datum reference will be, and very quickly auto dimension, in this case, all the holes and all the features, and save it. So again, you just need to tell it what you want to know, whether you import a file that's fully dimensioned or you manually roll through it to get all the dimensions that you want to see. Now, without changing anything on that original file, you can place as many parts as can fit on the table, no particular place. They can be as close as a human hair apart. Again, without doing anything, scanning that same barcode, tell it to scan the entire table. It will look at everything you've placed on there of the same part. It will then take all of those, in this case, 5 parts, overlay them individually on the CAD model, give you a big pass or fail on the screen, and you can see on the table, switch to there you go. You can see on the table red and green, and the parts are numbered as well to correlate to the inspection report. So an operator can very quickly tell which one's good, which one's bad, whether that bad is out of tolerance, missing feature, extra feature, whatever the case might be. It just doesn't matter. It very quickly tells them pass or fail and gives you a full report on all those features. Go right to QC Calc, John. Again, just trying to fly through. You can also then flip the screen if you would, export the data into an SPC system such as QC Calc that we use. And with QC Calc, you can look at the trends and see how good or how bad you've made a part over the past year. And then a really neat feature is the ability to export that to a PPAP. AS9100 is a very common PPAP used throughout the industry. This is real time as it loads the information into that. So if anyone fills out any of these forms now, you know how long the process is. You're going to copy and paste. You're going to input data. It takes a tremendous amount of time. Our system allows you to export all that data very quickly into a form, whether it's a predetermined form, a customer form, or some form that you've created, and create that data in seconds, not in hours, and send your customer that report. I'll just go right to the 2.5D, John, and I'll cover the 2D again for a minute. The two-dimensional system that we just showed you has the ability to do unlimited repositions. So any length of part can be put on there. It does reverse engineering, where you can take a part and make a CAD model out of it in seconds. We have many different table sizes, anything from 2 by 2 feet up to, sky's the limit, but 4 by 8 is a pretty standard size for us. This particular table today is 60-inch by 40-inch. This table here also has, of course, all of our options, and one of the options we're going to jump right into now is the 2.5D option, or it's called Surf Scan. The ability to take very simple three-dimensional parts and measure them. Now, when I say measure them, we're measuring what we can see. And again, I highlight or emphasize the fact that this is very simple parts. We're going to be able to take dimensions off of the surfaces, off of the overall lengths, off of the bolt hole patterns, everything we can see. It can't look around a corner, it can't see underneath it, but everything within sight, it's going to be able to measure in an X, Y, and Z environment, and then overlay that data onto the part. While it's doing it, I can tell you that the machine at all levels is self-calibrating, and that it has calibration artifacts that come with it that allow you to calibrate it. Factory says do it once a year. We'll teach you how to do that. It's very simple to do it. You can do more often if you want to, but the whole point of that is you don't need us to come back and do it again. You'll be able to do it on your own, which is considerable cost saving. Now, the tolerance on most of our machines, the one in particular today that we're on, is plus or minus 35 microns, which means plus or minus 0.00138. So very typical for our sheet metal industry. Again, multiple table sizes, plus or minus 0.00138, reverse engineering capabilities, automatic calibration, and automatic reposition of a part. Again, going back to the 2.5D here, it's taking that data that it sees from the top down. You can see it can't look around the corner. It will then overlay that onto that CAD model. And with the samples that we've taken, such as surface to surface, height, angle, and flatness, give us the data from that part. You can then create a report, very similar to the 2D report. It shows the data, shows it passed or failed, shows the tolerance you applied to it, gives you the measured and the deviation from height to height. You could rotate this part and do it again. The problem is those are two different files. John, let's roll right into the 3D so we can spend a few minutes on that. So again, very quickly today, we showed you the 2D. It's as simple as laying a part on there, no particular place, scanning it, comparing it to the CAD model, putting multiple parts on there, scanning it, comparing it to the same CAD model. 2.5D can do parts up to the full table size, and up to 14 inches tall, is able to measure height, slope, and flatness. And then we roll into the full 3D version. Full 3D version introduces another camera and another projector into the picture. The operator simply places a part in the center of the turntable. It's an air-driven, belt-driven turntable. You'll place the part there, and much like you saw it do, if you notice in the 2.5D how it flooded it with light, you can place the part on there. It's going to begin scanning it. It's going to rotate it, scan it again, rotate it, scan it again. Rotations are determined by you, the user. Typical is 4 to 6. You can certainly do more. 3D is very much different than 2 and 2.5D, as it picks up everything. Everything meaning any hardware, any pin nuts, any studs, anything you place on that part. Weldments, different pieces, it will see it. The 3D is limited to a 39-inch window, 39-inch in the round you see there, up to around 24 inches tall. It still has a tolerance of plus or minus 35 microns, or plus or minus 0.00138. You notice in the 2D, it took about 10 seconds to check a part. The 2.5D took about 2 minutes to check a part. The 3D takes about 5 minutes to check a part. So it still holds a tight tolerance. It's still very automatic, but it does take 5 minutes. There's nothing I can do to speed that up. You'll see it building the part on the screen as it's rotating it throughout. Now in the 3D world here, you could flip the part over and continue scanning. So if there's something it couldn't see, you could flip it over and begin, and it's going to merge everything together. You could hold the part in the air with a plunger. You can do all kinds of things and be able to merge all that data. Now after it's done scanning, which is almost done, I think that might have been, this might be the last scan right here. You're going to see it bring all that data, similar to the 2D and the 2.5D, but bring all that data into the 3D software. You can then automatically overlay it onto the full 3D model. And this 3D software does have the ability to import virtually any native file from SolidWorks, ProE, CATIA, anything, Inventor. Bring that data in, overlay it onto the file. You can utilize color banding if you want to, and you can look at trends of what direction it's going. Blue would be in the negative, red would be in the positive, versus underbent versus overbent, just for a visual for the engineer to see. I like numbers. So of course, you can turn on your dimensions. You can get all the dimensional dimensions you want to. Dimensional dimensions, that's a real thing. From any datum that you want to, with true GD&T from, again, any datum you want to, multiple datums, A, B, C, D, as many as you want to. After it's brought it in and overlaid it, you can see the green and red dimensions. You can then open up the report. The report will show basically what you've seen on this screen. And that report will show the values, the pass or fails, the deviation, the color map if you choose, and all the information. You can do full inspection as well as reverse engineering in the 3D and the 2D. It's very simple to do. It's a very popular thing to get done as well. John, why don't you just flip to we're almost out of time. Why don't you flip to the video of the robot real quick so we can show that while I finish a couple of things that I want to talk about. So we very quickly showed you the 2D, the 2.5D, and the 3D. We also have the ability to work with you on either a robot that you have or a robot that we can offer, or a robot that Mid-Atlantic, Southern States, etc. can offer, and the ability to very much automate your process by simply putting parts on, stacking them, moving them, stacking them in a pass-fail orientation. So this can be as automated as someone wants to, or as manual as someone wants to. All of our machines at all levels are designed to be right out on the shop floor. They don't care about dirt, dust, vibration. You should never have to replace that glass for the life of your machine. What you should notice about our system is it's probably 10 times as fast as anything else you'll see out there, with a tolerance right in line with sheet metal, with many different table sizes, many different options, and didn't really get into it, but different tolerances that we could basically provide you with. I think that is where my time slot was supposed to end. So with that, I'm going to turn it back over to the host, which is Mid-Atlantic, for any questions that may have popped up. Chris, are you still there? I don't hear them.
Hello, Dave.
Go back to the 3D. Yes.
Sorry about that.
There we are.
Kevin, sounds
I am here.
That's okay. All right, very good. Well, I didn't want to run over my time, and I was told to go to about 25 after, so I did that. And
Okay, I know we had a little late.
One at,
yeah, we had a little late start, so
so
we were going to let you go a little bit more if you have final thoughts, and then we'll kind of quick kick it to a question and answer.
All right. Really, my final thoughts are, we're very flexible, and then one thing I didn't mention is we're also modular-based systems. Someone can start with the 2D, they can add the 2.5D later, they can add the 3D later. So we're very versatile as far as modular-based with our customers to be able to add things. What you're going to find is there's virtually no maintenance on the machine. The machines just run and run and run. The cost versus running factor is very, very low. And I think we have a fantastic solution for anyone doing any kind of sheet metal, whether it's laser, punch, water jet, plasma, router, stamper. And we cover all industries, everything from sheet metal to gasket to laminations, you name it. With that, I think, Kevin, I'd be glad to answer any questions that may have come up or
Yeah, we've had a few questions coming in, and you may have already touched on them, but this one, does it have any limitations on materials of the inspected part?
It does not. We are using light. In particular on the 2D, we don't care if it's wood, plastic, metal, anything like that. There is nothing that bothers us. Same with the 2.5D. I will tell you full disclosure on the 3D, as parts become very shiny, whether it be polished stainless, polished aluminum, anything like that, we do actually have customers spray a talc powder on it to see it, but the material itself does not affect us at all.
Great, well, thank you. And here is another one coming in now. What are typical consumables and what is typical maintenance and annual costs?
Yeah, so the only annual maintenance cost that we actually hope that you admire too is software maintenance, and that is it. It's about $1,200 a year for someone to get it. But as far as annually keeping the machine up, there's nothing that we need to provide you. You have all the calibration artifacts. You're able to wipe the glass off yourself. There are a couple of filters on the side that the guys will show you to go to Home Depot and just get another one. You don't need to buy one from us, kind of thing. And that's it. It's a pretty self-sustaining machine, self-calibrating. There's the filter John's pulling off, nothing special. And you'll take care of it yourself. So your cost of annual maintenance is almost nothing other than we hope you'll get the $1,200 a year annual maintenance, which also gives you full support. It's not mandatory.
Excellent, great. And we do have one more. How soon can I get one? Is a customer question.
We have them in stock. We still have inventory this year. We try to stock it so that it's available when everybody wants one. So we have them ready.
Well, that's great to know, and we really appreciate you, Dave, taking the time. John, thank you very much for showing the people the InspecVision and giving a great presentation. So,
right,
with that
good.
being
We appreciate
said,
your time.
Yep, we will actually be transitioning now to our next session, which is flow water jets. So for anyone out there interested in water jets, head over there. But again, thank you guys, and we will talk to you later.